This short video illustrates each step in a 1-hour tutorial class about spectroscopy conducted in an active learning classroom. The strategies you will see basically allow instructors to optimize how they facilitate tutorials, particularly when they find themselves in a situation where there's one instructor and many students.
What you see in Raman spectroscopy is that the most intense spectral feature in a Raman spectrum is associated with this symmetric stretch, and it's always associated with the symmetric stretch because during a symmetric stretch you always see the greatest change in the polarizability in the molecule. Okay, so that's one thing I'm going to note because you're going to need that information.
Here you notice the class begins with the instructor giving a short lecture, usually for about 5 minutes. Here the instructor identifies and reviews fundamental principles and concepts learned during the past weeks, which the students will need to use during the tutorial that will sort of help them solve the problems being discussed and help them rationalize their answers.
But I've summarized it on your television screens now. So you can see the 712 peak is a PQR band structure. It's very intense, very strong intensity, VS.
Next, you notice the instructor explains the task. Through this explanation and summary, the instructor is also trying to activate students' prior knowledge.
I've already given you a fairly good hint what that will be. So what you need to do is assign those bands in that table. Okay, so could you go to the whiteboards, perhaps just scribble up the frequencies and tell me what kind of transitions you're seeing associated with each of those bands. Is it a fundamental? If so, what kind of fundamental? Is it an overtone? Is it a combination band? You have to decide. And you need to rationalize that. You need to tell me why. How is the information in that table supporting your particular assignment? Okay, so if you could pop to the whiteboards. You clearly are the closest to the whiteboard, so it looks as if you're going to be doing this. So scribble the numbers down on the whiteboard and then help your colleague decide on the assignment. Oh yeah. Okay, so who's doing the scribbling?
We're having like intense discussion.
Well, I can hear, but I would need someone at the whiteboard scribbling as well.
Okay.
Students then work on the problem in small groups. You notice how the instructor tends to float when the small group work happens. He gets students to take part actively in the process by doing a few things. First, he gets each group to assign a scribe to scribble the solution to the problem on the whiteboard. Second, he reminds the group members to think about the problem collectively and support the scribe in answering the problem. Then, he's looking at who's doing what they're saying, and which group needs help.
Okay, so you've managed to assign, those are the three fundamentals. So why did you assign 3312 to be asymmetric? Why is it an asymmetric bend? Asymmetric stretch rather. Highest frequency, that's certainly true.
This 2,800. It's not very strong.
It's not very strong. That's potentially PR. So why does it have to be PR?
It's not bending.
So it's a, what kind of, is it? It's not perpendicular, it's parallel. So the dipole moment is changing parallel to the bond. Okay?
The instructor also asks a whole array of guiding questions instead of providing an answer, to force students into making meaning, drawing relationships. With this facilitation approach, students get immediate feedback while solving challenging problems, as the instructor can see right away the mistakes that they are going to make and be able to provide just-in-time feedback.
Or three absorptions associated with fundamentals, because you've got a fundamental asymmetric, a fundamental symmetric, and a fundamental bending. So if it's a combination though, what's a combination of?
First and top.
Yeah.
Second is overtone.
Overtone of what?
Bending.
Absolutely.
Then bracket bending.
I'll explain why or try to explain why the Q branch disappears in a moment. Okay. Okay, so you've got combination 2,800. What's that a combination of?
Of the 712.
Yeah. So why are you having trouble assigning 1,400?
As in, actually we did like elimination method, like we just, as in we are firstly identified symmetric because it's like the very strong intensity and also it is Raman active, so that's why we chose symmetric for the.
Yeah, and that's correct. That's absolutely correct.
Yeah, then after that we just try and error and then we found out the combination was the.
But what about 1,400 though?
The class progresses interactively and the teacher is as much a participant
I mean, you
as
expect
a guide
the overtone
of the
to be
discussion.
slightly lower frequency than twice. So that is.
So that's the first one. But I thought you said first one was
Okay. You'll notice that its intensity has dropped down to, as well, which is something you expect.
Okay.
Okay.
But this first overtone is it for bending?
It is, yeah. It can. That's the only thing it can be for, because.
Running tutorial classes this way is certainly more rewarding for instructors. But students also recognize the many benefits it brings.
We'll go into that in a moment. Okay. One thing you can think about is what's the symmetry of the vibrational wave functions, and it has to do with that. And I'll tell you about that in a moment.
This video has illustrated how one instructor uses various strategies to more effectively engage with his students in the classroom. In the process, he has also clearly generated active interaction among students and promoted peer learning. These evidence-based active learning practices can be applied in basically any type of module, and most instructors find they develop these skills quite quickly.